Well, let us tackle this following question that combines the parallel series and parallel connections. So two resistors R1, which is equivalent to 2.5 kilo ohms, and R2, 4 kilo ohms, are joined in series and are connected to a 100 volt supply. The volt drop across resistor 1 and resistor 2 are measured successfully. Both resistor 1 and resistor 2 are measured successfully by a voltmeter having a resistance of 50 kilo ohms. That is voltage in between resistor 1 and resistor 2. So find the sum of the two readings. To begin with, we shall start with the total circuit resistance, and that is where we are going to assume that these R2 will be our resistor in series with the equivalent resistance of 50 kilo ohms, which will be somewhere here. The 50 kilo ohms which will be somewhere here, and this the 50 kilo ohms which will be somewhere here, and in this we shall understand that total circuit resistance is 4000 ohms plus 2.5 kilo ohms is equivalent to 2500 ohms multiplied by 50,000, which was the 50,000 kilo ohms, 50,000 ohms. We just converted the 50,000 kilo ohms into ohms over 2. So this is the calculation in parallel, and we find out that the total resistance is 6,381. Now the current flowing in will be 100 divided by 6,381, and we both know that I is equivalent to V over R. That is where we got our calculation. Voltmeter reading V1. The V1 here will be voltage is equal to IR, which is our current, which is the unknown current for now, multiplied by 2,381. Calculating this, or we can leave it like that and multiply it by this. We will obviously get a voltage of 37.3 volts. Working out on the same, we are going to get the total circuit resistance of this circuit number 2, and for this we are going to assume that the resistance the resistance 1 is in series with parallel resistance of 4,000 and 5,000. Working out, we get this for 62,203.7 ohms, and working out the current, we are going to get V over R, which is 100 over 6,203.7 amperes and 0.7 ohms, and that is denoted by amperes. So the voltmeter reading of volts 2 is current multiplied by 3,703.7 ohms, which is equivalent to 59.7 volts. So adding up the total sum is V1 plus V2, which is the 37.3 plus 59.7, which is equivalent to 97 volts. So that is basically the understanding of equivalent calculation in basically circuits in series and circuits in parallel.